Hello, welcome to Intermediate Algebra today. On Friday we had talked about order of operations. So today we're going to pick up with applying order of operations and using them in some real world situations. Please be sure if you need some more time to write, so especially on this vocabulary part, that you pause the video as you need. Take that time to write and just resume it once you're done. So our first vocab word, our goal for today, our objective, is to translate words into mathematical expressions. Our first vocab word is a verbal model. A verbal model is a model that describes a real-world situation using words as labels and mathematical symbols to relate the words. So for example, if I were to say 4 less than the quantity 6 times the number n, that's a verbal phrase that's describing a real-world situation using words. If we were to translate that into a mathematical model, well, a mathematical model is just an expression, and we learned about those a couple days ago. It's just an expression or an equation that can be created from a verbal model by replacing words with numbers and variables. So for example, we would translate 4 less than a quantity 6 times the number, n, translate that verbal model into 6n minus 4. Rate. A rate is a fraction that compares two quantities measured in different units. So for example, we could have 400 feet in 10 seconds. They're comparing feet to seconds. It's a fraction that's comparing the two quantities. We could rewrite that as a fraction. Unit rate, very similar, except that it has 1 as the denominator of the fraction. So that's super important. Make sure that you remember that it has 1 as the denominator. So if we were to change 400 feet in 10 seconds to a unit rate, if we were to change that rate to a unit rate, we'd write 40 feet in 1 second. So we would just reduce our fraction. Okay. There's also several math terms that tell us what operation to use when we're working with these verbal phrases. So if we have the words sum, plus, total, more than, or increase by, we're going to have addition. If we have difference, less than, minus, or decreased by, we have subtraction. If you have times, product, multiplied by, or the tricky one of, we have multiplication. And then for division, if you hear the words quotient, divided by, or divided into, that's all telling you, hey, you need to use division. So for our first example, we're going to use the table above to translate each verbal phrase into a mathematical expression. So I did this earlier. I'm just going to place each of these just off to the side here, and we'll have a little bank to choose from. Okay, so for the first one, we have total. What's that telling us to do? Total is under addition, so we're going to use addition. What is the total of 25 and 12? Now, we're just writing these as expressions. We don't need to simplify them. So I'm looking for one that says 25 plus 12, and it's small. I'll make it larger. There we go. So here's our first match. For the next part, we have more than. Ooh, that looks like, it's addition again, more than. So what is 3 more than 6? We're going to write 6 plus 3. For of, that's that tricky one I talked about, multiplication. 1/2 of 10 is, so of, that's telling us just multiply 1/2 and 10. And then is means equals. That's one that was not in the table. Is equals. Well, 1/2 times 12 is 5. For this next one, 120% of 40 is, so there's of, tells us to multiply, is means we have an equal sign. 120%. Okay, if we're working with percents, can we multiply with it in this form, like 120 with the percent symbol? No, we can't. So we need to convert that to a decimal. Well, in this case, it's over 100, so we've got one whole, so here's the one that matches. And then 20% is 0.2, so 1.2 times 40. And we know that one whole of 40, or 100%, is 40. And if I multiply 0.2 times 40, I get 8. So 40 plus 8, that's 48. Our next one, 60% of 100. I'm going to multiply 0.6 or 60% in decimal form times 100, and I get 60. And our last one, 1/3 of 90 is. So this is 1/3 multiplied by 90 equals, here we go, 1/3 multiplied by 90 equals 30. I got a few left. Twice. Ooh, that's not listed in the table. But if I'm saying 2 times a number, that's the same as saying twice. So 2 times the number n would be 2 times n, or 2n. If I have squared, a number squared, so we'll call that number n, and that's also multiplication. You're saying n times n, or we can write it as n squared using that vocabulary word, squared. All right, for minus, we know that means subtraction. A number minus 5, so we're going to take 5 away from that number, or n minus 5. Decrease by, again, we're subtracting. Decrease by. If a dozen is decreased by 10, oh, so we've got a dozen, and we're taking 10 away, or 12 minus 10. Does it say is? Do we need to solve that? No, it just says if a dozen is decreased by 10. Divided by, the quotient, when 8 is divided by 4, we only have 2 left, so we probably know, and they're the same. So we're going to divide 8 by 4. The quotient means division. The quotient when 4 is divided into 8. That's the same thing. We're going to divide 4 into 8. How many times does 4 go into 8? We're using division, 8 divided by 4. Okay, let's go on to the next slide. Okay, on this next page, example 2, we are rewriting, I should have directions up here, but we're going to rewrite these verbal phrases as mathematical expressions. Or equations, if that's what they are. Okay, so the first one, we have 4 less than the quantity 6 times the number n. Okay, less, that means subtraction. So we've got our subtraction sign. If it's 4 less, we're not saying 4 minus something, we're taking 4 away from something. So we're going to have minus 4. Like if I said, I'm going to give you 4 less candy bars than I give Tanya. You're going to take whatever Tanya had and subtract 4 less. Then the quantity 6 times the number n, so we know times is multiply. What are we multiplying? We're multiplying 6 and n. Okay, now are we saying -4, 6 times n? No, we got to read into this. 4 less than the quantity. Okay, so at the very end, after I've multiplied 6 times n, then I'm subtracting 4. Oh, so when I write this as a mathematical expression, I'm going to have 6n, and we're taking 4 away. 4 less. 6n minus 4. Okay, example 2b. We have 3 times the sum of 7 and a number y. So we're multiplying 3 by this whole last part. 7 and a number y. Okay, so I'm going to write 7, and did that say sum? Yes, so I'm going to write 7, sum is addition, 7 plus y. Oopsie. 7 plus y, and then I need to multiply 3 by that whole part. So I need to use parentheses and have a 3 out times everything behind the parentheses. So 3 times 7 plus y. For C, we have the difference. Ooh, difference means subtraction. The difference of 22 and the square of a number m. Okay, for this one, we're starting with that 22. We want the difference of 22 and that number. So it's 22 minus, and we're squaring, what are we subtracting? The square of the number m. So we're going to take m squared away from 22. And that's all we have to write. For our very last one on this page, the quotient when the quantity 10 plus the number x is divided by 2. Okay, quotient, that's division. And we're dividing by 2. So we know that let's write this as a fraction to represent division. So we know in the denominator, we're going to have just the number 2 because we're dividing by 2. So that means in the numerator, what was it? 10 plus the number x. So we're going to have 10 plus is addition, 10 plus the number x. So kind of piece by piece, we can put this together. 10 plus x divided by 2. All right. For this next one, we have clear this out. We have a real world example. We're cutting a ribbon. Okay, so we have a piece of ribbon that's n feet long, cut from a ribbon that's 8 feet total. Write an expression for the length in feet of the remaining piece, so whatever's left over. Okay, so for our problem tip number 1, draw a picture. Here's my ribbon. It tells us that the ribbon total is 8 feet long. So I'm just going to draw this out so that we know that, hey, this whole ribbon across this whole rectangular picture I drew is 8 feet. And I'm going to cut it. We don't know how much we cut, so we're just going to call that piece that we cut off N. Okay, so this piece is what I'm cutting away. This I'm going to call N. It's N feet long. That's how long that piece was. And we need to write an expression for the length that's left. So this whole other left side of my snip here is leftover. How much is that? How do we write an expression for that? I'm a little confused here. So we're going to try problem tip number 2. We're going to use real numbers for a concrete example. Okay, so let's say that we had an 8 feet ribbon. We had 8 feet of ribbon. Oops. Ribbon. And we cut 2 feet off. How much is left? And we know that this answer is going to be 6 feet. 6 feet are left. Why? Why do we know that? What operation are you using? I'll scoot this up so we can see. Oopsie. What operation are we using? Well, if we cut 2 feet off, we are subtracting that 2 feet. 8 minus 2 gives me 6. So we're going to do the exact same thing in our example where we don't know how long the piece is that we cut off, so we called it N. That will work for, oops, that's a 2. That'll work for whatever number N is. So we're just going to write for the piece left over, it's 8 minus N feet long. And that's our answer. We took 8, we subtracted N, so the section left over is 8 minus N feet long. And that's as close as we can get to whatever that actual length is. Just plug in, substitute in a number for N. All right, our very last example. We have Juice It, my favorite smoothie place to go. It's my little sister and I having our Juice It a couple weekends ago. We're going to pretend that you work there with 5 other people. We're going to delete all this. All the workers put their tips into a jar and share the amount in the jar equally at the end of the day. We're going to write an expression for each person's share in dollars of the tips. Okay, in order to do this, we don't know how much we actually have in tips, and it's going to change from day to day. So we're going to pretend that T is the amount of money in tips. If you work with 5 other people, that means we've got you and 5 other people. That's 6 total people. So you're going to take the amount that you get in tips, T, and we need to split that. Well, how are you going to split it evenly? We're going to take T and we're going to divide it to all 6 people, or T divided by 6. And that's all we need. That's our expression. Take your tip money, divide by 6, boom. That's how much you go home with at the end of the day. For this last example, cell phones, you have a basic monthly charge for cell phone service is $30. And that includes 300 free minutes. So every month you pay $30 for those 300 minutes. You pay a fee for each extra minute that you use. 1 month you paid $3.75 for 15 extra minutes. You need to find your total bill if you use 22 extra minutes. Okay, so we know how much we pay monthly. We know that we paid $3.75 for 15 extra minutes, but we have no idea how much 1 minute cost. But if we know how much was it? 15 extra minutes cost, we can easily figure out how much 1 extra minute will cost. We just need to divide and find a unit rate. I'll write this down. Find a unit rate. So in order to find that unit rate, we're going to take that $3.75 and we're going to divide that by 15. Because we want that denominator to be 1. And when we do that, type that into our calculators, we're going to get 0.25 over 1. So that equates to, hey, you're paying, we're talking money here, so you're paying 25 cents per per 1 minute. Okay, so that's helpful. Now we need to find our total bill if we use 22 extra minutes. Well, we know that we start with $30 no matter how many minutes that we use, and for every minute we spend 25 cents if we go over that total. So we start with 30 every month, and we're going to add on to it 25 cents times every minute. Let's call that M. So 25 cents for every minute plus the 30. That's our that's our model from that verbal, our mathematical expression from that verbal model. Okay, so we need to now evaluate the expression when M is 22. So if I'm going to evaluate here, for M equals 22, we're going to plug 22 in for M, and we get 30 plus 0.25 times 22. And we need to simplify. We get 30 plus, and then 0.25 times 22 is actually 5.5. And if we add those together, we get 35.5. So our total bill then is going to be, we need to write this in dollars, $35.50. All written, or all figured out because we could write a mathematical expression from a verbal model. I'll just highlight that last part so we know that's our answer. Oops. And that's it for our lesson. Now you can move on to your homework, which is right here. It's on page 18 in your textbook, and you're doing numbers 3 through 12, 14 through 25, 31, and 35. And that's it for today.